Hello everyone. So today we are going to solve two miscellaneous problems related to backtracking, and those are actually very famous questions, could be asked in many good interviews. Okay, you could expect these questions. So one is Sudoku solver and another is N queen problem. You most probably have heard about these problems also, so we'll solve this kind of problems today. So in the previous session we have seen that a simple basic algorithm we have learned in the previous session, that is related to, like, once you get the solution you have to return it from there, or it's like you have to try solving. Okay, for ith part, let's say you have solved, then you again solve until you get the solution. Okay, if you didn't get, you backtrack. So this is how we learned in the previous problem, in the graph based problem, that I filled this particular value with, let's say, o or x or whatever. Okay, and then what I'll do, I'll try to solve the whole path problem with this particular values at this ith row and jth column, and then I'll try to solve the full graph with this particular value, and then I have to see whether it is possible to move ahead or not. If not, I'll push back and pop it out, I mean backtrack that. Okay, so same for the Sudoku. You might have known that Sudoku is nothing but 9 cross 9 grid. Okay, with 3 3 cross 3 small subgrids inside it. Okay, with 3 cross 3 small subgrids inside it. Okay, and 1 to 9 values you can enter. There are some rules. 1 to 9 values you can enter. No duplicates in same row, no duplicates in same row or same column. Okay, so if here is 1, then here in full column 1 should not be there. In this full row also 1 should not be there. Okay, and in this 3 cross 3 subgrid also, this particular value should occur once only. Okay, and no duplicate in 3 cross 3 subgrid. Okay, no duplicate in 3 cross 3 subgrid should exist. Okay, so we knew this, and some of the values are already given, some values are already given, and in the question you will be given 0, wherein 0 means blank cell where you have to put some value. Okay, now we know that there is only one possible solution to Sudoku. Okay, there are not multiple possible solutions, so there is only one possible solution to a Sudoku. Now we need to solve this. Okay, so our basic thing is what, we try to put wherever there is a 0. Okay, that means a blank cell. We try to put all values from 1 to 9. Okay, we try and put all values. So let's say I try 1. Now with this value as 1 in particular ith row and jth column, I try to fill whole Sudoku. With this value as 1, I will try to fill whole Sudoku, and if I get it correct, I will return it. I will return it as true. It means I've got it. No need of doing it with another value. Okay, because there is only one possible solution and I got that. But if I didn't get this Sudoku completely done with this value as 1 over here, okay, so when 1 was here and I try to solve this Sudoku and I fail at some point, and that means I need to backtrack. I need to pop back this 1, and then I have to try again with the 2, again with 3, if not with the 2. Okay, so this is how you will move. So basically what you have to do, so let's say you have this void solve function of Sudoku. Okay, now you have passed the ith row and jth column where the value is 0. Okay, what you will do, you will try and solve for k 1 to 9. So I'll try to put k is equal to 1 to k is equal to 9. Okay, if is possible, now this is possible is to check those conditions of same row same column, with I, j and k. That means at ith row and jth column, at that particular cell, can I put this k value over there? How can I check? This k value should not be there in any of the row. It should not be there in that row, should not be that in that column, in jth column, full jth column, and should not be there in 3 cross 3 subgrid. If this three conditions exist, that means if is possible is true, what I will do, I'll put grid of I, j as k. Okay, so now I have put this, finalized this, and then I will try to solve Sudoku. So this is recursion function. Again, I'll try to call this Sudoku function. Okay, and if it is true, I will return. That means I got the solution. I got the solution. Otherwise, else, if this solve is not true, that means I am not able to solve full Sudoku. Okay, then what will I do? Else I'll do for else what I'll do, I'll make it again 0, and that means I am backtracking it. So this is nothing but the backtrack part of it. So I'll backtrack that. I hope you got. Okay. Okay. Let's solve it. It's okay. But we have seen that for the solve Sudoku question, we need if this solve, then we will return. If this solve Sudoku is done after one point of selection, so we make it feel and then we do a backtrack and we try to feel the whole Sudoku. If it is done, we'll return true. So we need this solve function of Sudoku as the Boolean function. Okay. So let's just make a bool solve function wherein you will just pass the matrix itself. Okay, you have ns matrix dot size. Now what you need to do is you'll just go from I 0 to n, j 0 to n. Now you have to fill it only if the matrix ij is 0 at that particular point. So if it is 0, you need to fill for ks 1 till n, till 9, and you need to check for k1 to 9 if it is possible. So if you have to feel it, so if is possible with the I and j row and k as the value over this matrix, if it is possible, then you will make this matrix of ij as k and you will try to again solve it. So if it is solvable from this point, so if solve again this matrix, then you will return true. Otherwise you will pop it out. So else pop it out means you will make it 0 again. You will make it 0 again. Okay, but after traversing through 1 to 9 for this particular ij as 0, you didn't find anything, then you will return false. That means that you are not able to find anything from this. Otherwise, anyways, this is true. So let's say your Sudoku is already solved, fully solved. So no ij as 0. So this part is not there if part, then anyways you have to return true. But if you have one empty part, after trying all possible 9 values, you didn't find anything which is solvable for this matrix, then you will return false. Okay. Now the thing is to create the is possible function. So is possible has int I, int j, int k, and your matrix. Okay, let me take one x from 0 till n. So if matrix of this particular row is fixed and column is varying is equal to k, that means it is false. If matrix of this particular row varying and column is j, if it is equal to k, again it is false. And for 3 cross 3 subgrid, we have this formula that matrix of x into I by 3. So for 3 cross 3 subgrid, you have this formula matrix of it. The row part should be 3 into I by 3 plus x by 3. Okay, you try and solve it, you will get this 3 cross 3 subgrid in this particular manner. And 3 into j by 3 plus x mod 3. Now, this is where you will get the 3 cross 3 subgrid. Now, this is equal to 1, then you will return false. This is little bit, you have to make and verify and make the formula, or you could remember 3 into I by 3 plus x by 3 and 3 into j by 3 plus x mod 3. Okay, then we will return false in this all cases, otherwise we will return true. Okay, So I just need to call this solve function with the matrix as passed, and I'll get the answer. I hope you got. Okay, so we are done. Okay, so let's solve the n queen question, which is the second question. Now, n queen problem says that you are given an n cross n grid, okay, and you have to place n queens such that no two queens can attack each other, such that no two queens can attack each other. Okay, so let's say there are four queen problem. So you have four queens. Okay, so and you have to place four queens. This is 4 cross 4 grid. So let's say you put one queen over here, and you cannot put in this diagonal. This so queens can attack in all eight directions. You might know that. Okay. Okay. So queens cannot attack in all eight directions. So you cannot put over here. You cannot put over here. You cannot put over here. So let's say second queen you put over here. Now this cannot attack this queen also. Vice versa. Cool. Now third queen, you might put it over here, but this queen will be attacked by here, and this queen. So this placement is again wrong. So what you'll try to do again? Try putting this first queen at second row, maybe here, and then this queen over here, and then this queen over here, and then this queen over here. Could be one of the possible solutions. Now you need to think of those all possible solutions where you can put the queens, and you have to return all possible solutions. So here the case is not like you have to return only one solutions, because there are many solutions which exist. So what we will do is, let's say you'll be given n cross n grid. Now how you will do it? Okay. So for the backtracking purpose, we may need a call. Let's say we can do it two ways. Okay, we could pass rows and we could define columns, or we could find columns and we could find rows. So as you know that there are n cross n grid, and we have to place n queens. So each queen should be in at least one column, okay, or each queen should be in at least one row. Okay, so what I'll do is I'll fix the columns. Okay, fix the columns and find the rows. Now what do I mean by this? Is in my solve function, I have a column, okay, which is fixed, and then I have n, and temp is just vector of int, result is vector of int, and one board, which is just n cross n board or grid, queen board, which is initially 0, and as and when I put the queen at that position, I make it 1 to check whether I can put another queen on that same row, column, or diagonal. Okay, now what you will do is, the base condition would be all columns should be filled. So if you have reached nth column, that means you are done. So you will push back temp in your result, and you will return. Otherwise, for this particular column, let's say your initial column is 0. So for this n cross n grade, initial column is 0. Okay, so you'll start by checking with row 0. Can I place for row 0 column 0, and then row 1 column 0, and then row 2 column 0? Okay, so I will traverse the loop for row. So my row could go from 0 till n. Okay, and what I will check is possible this combination of row and column for this particular board. Is it possible to put the queen at this particular row and at this particular column? If yes if yes then I will put it. So I'll push back my row into my temporary answer, and this row is 0 based, but we need answer in 1 based, so I'll push it in the one based indexing. Okay, so I'll push this row plus 1 in my temp dot pushback. So let's say I've made it column wise. Okay, so for 0th column, I make it in second row. For first column, I have to put it on first row, something like that. Okay, and then also what I need to do is at this particular row and column, my queen is already placed, so I make it 1 for sure, and then I'll go and solve it for next column now. So I'll go and solve it for next column with the column plus 1 and whatever is your defined parameters, and then you have to do the backtracking. So you have to pop back, and and you have to make a row and column at that particular as 0 also. I hope you got. Now the main thing is to define the is possible function. Now you know that let's say this is my 3 cross 3 grid. Okay, and initially I'm putting it for column 0. So for column 0, let's say I place the queen over here maybe. Okay, now this queen can attack here, this queen can attack here also. So I cannot place the queens over here. Can I place the queen over here? Yes, and I can place one queen over here, but this can attack it. uh, okay, let's assume that this is the correct solution. Okay, then for column 0, as you are placing it column wise, you have 8 directions in total. Okay, these are the 8 directions which you need to check for each possible condition. Okay, now for column wise you are placing at this column, okay, at column 0 only. So for sure again you will not place at column 0, you will check for column 1 only. So let's say how you will place for column 0, you will check where can I put. So you found that for column 0 you can put at third row, and then you found that for column 2, you could place at maybe row 1, and then for column 3 you can place it row 2 maybe. Okay, so this is the assumption which you have made, or this is the correct statement. Then you go column wise. Then of course when this queen is placed, no queen should be there at the top or bottom of this queen, because you are feeling it column wise. Okay, and you're feeling it in this direction, from column 0 to column n. So anyways when you are at column I, you just need to check for 0 to I. So this you didn't need to check. Let me change the color. This you didn't need to check. Okay, because you're placing it column wise, so nothing should be there on top of it. Okay, left side you need to check that you might have placed on the same row, because we are not checking on the rows, we are mainly checking on columns while passing. So this side you have to check, and then this upper diagonal you have to check, and then this lower diagonal you have to check. So in is possible, only 3 conditions needs to be checked: this left row, upper diagonal, and lower diagonal, or I could say left upper and right lower diagonal. These are the only things you need to check while making is possible. I hope you got my point. Okay, so let's just quickly solve the question and you'll get a better idea over there. Oh, okay, so fine. Let's create a board of size n cross n, initially with zeros. Okay, and we have one temp. So you know this is subsequence related question where we need to make one temp and one answer or result arrays. Okay, and another result array. Okay, we try solving it for column 0, temp, result, board, and n, and we will return result. Cool. Now we have one solve. This is column. Okay, and this is temp, result, board, and n. Now the base condition is if you have done for all the columns, if you have reached column is equal to n, you will push back temp and you will return. Okay, otherwise You start from row is equal to 0. You'll go till nth row and you will do row plus plus. Cool. What do you need to do? You first check if is possible which combination, this row, column and board combination. If it is possible, you will push back this row in your answer, temporary answer. You'll make your board of row and column as 1, and then you will go and solve for column plus 1. If you're able to solve, yes, your temp will be completed and you'll push that in your result array. But if not, you need to pop back it. I mean, you need to backtrack. Both the things you need to backtrack. This you need to pop, and this you make 0 again. Okay. Now the only thing we need to make is possible. We have a row, we have a column, and we have board. Now, three things I need to check. Okay, first the left side row. So let me make one duplicate row as row and duplicate column as column. Okay, so first what I'll check, I'll just check the left side columns. So while duplicate column is greater than equal to 0, if board of this particular row and this duplicate column is 1, then you will return false. That means it's not possible. And you have to go left and left. Again, I'll initialize this row with the row and column with the column. Now you will go for left upper diagonal. So for that, your row will be greater than equal to 0 and your column should also be greater than equal to 0. So if your board of duplicate row and column is 1, then you will return false. And every time you do row minus minus, column minus minus. Okay. The same thing happens for the lower diagonal, but the row should be increased in that point. So duplicate row should be less than n and this should be plus plus. Column again you have to decrease. Okay, there's three directions you have checked. If you find it true, then you will return true. If nothing is false from this points. Let's see. And then you're done. Okay, so we are done with it. I hope you got both the questions, Sudoku and N Queen problem. So we are done with the uh, backtracking series over here, and there are so many miscellaneous problems which I would be posting down in the description, which you can go and solve it. Okay, simple algorithm which you just need to remember that okay, I have to do this, and just think of the step where you need to backtrack, and then you are done. We may go next with the graph or DP related problems. So stay tuned for the next video. Do like, share, and subscribe it with your friends. Bye bye.